Okay, so in this section, we want to talk about the linear programming. This is actually my research area. Okay, so we wanted to write an objective function describing a quantity that must be maximized or minimized. And this means we want to find maximum or minimum of quantity. And then using inequality describe what limitations in a situation. Use linear program to solve the problem. So what does this mean? So typically in real life, we always wanted to find the optimal solution. Means either maximum or minimum of the cost, maximize your revenue. But in real life, you always have constraints. Yeah. So all kinds of different kind of constraints. Yeah. So this is why you have limitations in a situation. So in order to model this kind of real problems, so we constructed a special type of questions. It's called what? Linear programming. Linear programming. Okay. So linear programming is a method for solving a problem in which a particular quantity that must be maximized or minimized and is limited by the other factors. The objective function is the expression that you wanted to what? Maximize or minimize. Okay, we call it objective function. And then the limitations, we call it what? Constraints. We call it constraints. Limitations, that will be your what? Constraints. Okay. So let's look at the example. A company manufactures bookshelves at the desk for computers. So let X represent the number of bookshelves and Y be the number of desks manufactured daily. The company's profits are $25 per bookshelf and $55 per desk. And write the objective function that models the company, the total daily profit, J. J will be what? 25 times X plus what? 55 times Y. Yeah. So, of course, if we wanted to maximize the profits, what will be the value for X? What will be the value for Y? Infinity, yeah, as many as possible. You wanted to maximize your, number of desks and also number of bookshelves. But we always have limitations. So what are the limitations? So this is the limitations are called constraints. We have already introduced. Yeah. So what are the limitations? So based on the the demands in the real world, and also based on the maybe the information from the sales. And do you all know that okay, so the company should not manufacture more than a total of 80 bookshelves and desks per day. Yeah, so they cannot manufacture. Or this is also maybe the ability of this company. This company is so small, you cannot make more than 80 bookshelves and desk per day. So X plus 1 less than equal to 80. And also based on the demand, you also to meet the customer demand, you also have what? Manufacture between 30 to 80 bookshelves per day. Okay, you can only otherwise if you manufacture too much, you cannot sell them. There is no demand, then it will cause you trouble. And then the other thing is the company also manufacture at least 10 and no more than 30 desks per day. Okay, this is also based on the information of the sales. Yeah. So now with all these constraints, so what will be the maximum profits? So we have the model here. Okay, so we have the model. So what will be the model? J equal to 25x plus 55. This is your objective function. So this is the function that you wanted to what? Maximize. Okay, and what are the constraints? The first one is the manufacturer constraint, x plus y equal to less than or equal to 80. These two are the what? The sales constraint. 30 less than equal to x less than equal to 80. 10 less than equal to y less than or equal to 30. Okay, so x plus y less than or equal to what? 80. And how could we make the graph? You always what? X plus y equal to 80. So x equal to 80 is x-intercept. Y equal to 80 is what? Y-intercept. Are you with me? Then you draw the line x equal to 80, and then draw the line x equal to 80 line, and x equal to 30 line, and y equal to 10 line, and y equal to what? 30 line. Yeah, okay, so then how many lines do you have here? 5 lines, yeah. So y is 10, 30, and this is 30, 10, this is 30, 80, and this is another line, is x plus y less than or equal to 80. Because we all have what? Equal sign here. We all have equal signs. All these lines are what? Solid line. Then after all the testing values, yeah, so you have to use the test value, which one you wanted to choose. So you choose 0, 0, yeah, and so all these things you will know that the intersection is right here. Okay, so this is the intersection, and then how could we find the maximum here? Okay, so how could we find the maximum here? Yeah, okay, so now let's go to the thing. Okay, so how could we solve this? Let j be, that depends on x and y. J is, yeah, so we graph all these things with the constraint. And where the maximum come from? The value of the object at each what? Corner or vertex. So the maximum or minimum of the objective function only occur at one of the corners or at one of the vertex. Yeah. So what does this mean here? So how many corners do we have here? 4. Yeah. After we find the intersections, we can find all these what? Corners. Yeah. And objective function maximum and minimum only happened at these what? Corners. So we find all these corners, yeah. So by using like okay, so this corner is easy, because we know that y is 30, x is 30, so this one is easy. 30, 10 is also easy, and this one comes from what? The intersection y equal to 30 and x plus y equal to 80. This one comes from y equal to 10, x plus y equal to 80 here. So you get all these what? 4 corners. Okay, so then what should we do? Substitute all these what? 4 corners into what? The objective function. So this is the objective. These are all 4 corners. So you have what? All these things. Okay, so what will be the maximum here? What will be the maximum of your revenue? It's 2,900. If you have 50 bookshelves and 30 desks, what will give you the minimum? What will give you the minimum revenue? You never wanted to have 30 bookshelves and 10 desks. Okay, that will give you the minimum. Okay, so perfect. That's the end of this section.